Hello everyone, welcome you all. This is Sanjeev for E4U Classrooms. In this video, we are going to discuss an NTA type, the NTA pattern JE mains. This discussion will be useful for students who are taking up NEET also. So let us start our discussion on this paper. This is the second mock test paper which I am discussing. So already I have posted one paper. So this one is the second paper which I am discussing. So let us go into the paper. The first question is the horizontal component of impulse provided by the string tension in moving from extreme point to the lowermost point. When it comes to the lowermost point, if actually the horizontal velocity becomes zero. So just before it comes, the velocity would have been, when it falls, the velocity, we know, when an object falls through a distance h, its velocity is root of 2gh. So velocity is root of 2gh, and then the velocity, the vertical velocity becomes zero when it comes to the bottommost point. So we know that the impulse is equal to change in momentum. The impulse is equal to change in momentum. So impulse J is equal to impulse J is equal to change in momentum. So change in momentum. Change in momentum, which is mass into V final minus V initial. V initial. So here V final will be 0 and V initial will be root of 2gh. So therefore this will be equal to minus m into root of 2gh. So this is the momentum experienced by the sphere, the ball. They are asking the momentum experienced by the string, provided by the string. So that will be minus of this value. So momentum provided by the string is equal to minus of this value. So it will become plus m times root of 2gh. So this is the answer. So next one, n divisions of main scale of a vernier calipers coincides with n plus 1 divisions of vernier scale. So if each division on the main scale is A units, determine the least count of the instruments. So each determine, you have to find we know that least count in terms of one division on main scale and one division of vernier scale is equal to A main scale minus A vernier scale. AM is the one division on main scale and AV is the one division on vernier scale. So the least count is equal to one division on main scale minus one division on vernier scale. So here this is going to be A and this one we will have it as AV. So this is equal to A minus AV. A minus AV. Now it is given that n divisions on main scale. So n divisions on main scale, one division on main scale is A, is equal to n plus divisions on vernier scale. So n plus 1 divisions on vernier scale. Vernier scale division we are having it as AV. So from this we get AV is equal to n by n plus 1 times A. So now least count as per the formula it is A minus AV. So it is A minus n by n plus 1 times A. So this will give us n by 1 by n plus 1. When you subtract n plus 1 minus n and n gets cancelled. So it is 1 plus 1 divided by n plus 1 times A. So this should be the right answer. This should be the right answer. Next, the current 4 ampere produces a deflection of 30 degree in the galvanometer. Find the figure of merit. The figure of merit is equal to 1 divided by current sensitivity. Current sensitivity is reciprocal of current sensitivity. So that will current sensitivity is theta by I. So this should be I by theta. Here theta is in radians. So that will be equal to I is 4 amperes and theta is in radians. It is going to be 30. So convert it into radians by multiplying pi by 180. So you are getting this is 6 4 are 24 by pi. 24 divided by pi. So 24 by 3.14 should be somewhere around less than 8. So it should be less than 8. Either it should be 7.6 or 7.5. You can check the calculation. Either it should be 7.5 or 7.6. So 24 divided by 5 you have to do. So you can check the answer for this one. Fourth question. The uniform disk of radius r and mass m is connected to a wall by a string of 2r. So this length is 2r. Then let us add this as theta. Let that angle be theta and this will be r. From this picture we get sin theta is equal to, from that picture we get sin theta is equal to r by 2r, that is 1 by 2. So this implies theta is equal to 30 degree. So from the geometry of the picture we find theta is equal to 30 degree. If you draw the forces here, the weight of the sphere mg will be acting downward and the tension will be acting in this direction and the normal reaction will be acting in this direction. When you resolve the tension into two components, I'll do it here. So this will be T cos theta. This will be T cos theta. And this is mg. And you have a normal reaction. This is T sin theta. And on the sphere, there is a normal reaction n here in this direction. N is the normal reaction. Actually, T sin theta will be in opposite direction. T sin theta will be in opposite direction. Because it is resolved like this and like this. It will be in opposite direction. So T sin theta should be equal to n. And mg should be equal to T cos theta. So you get T sin theta is equal to n. T sin theta is equal to n. And T cos theta is equal to mg. T cos theta is equal to mg. So when you divide this equation, you get tan theta is equal to n by mg, or n is equal to mg tan theta. Theta is 30 degree. So I'll put tan 30 degree. Tan 30 degree is 1 by root 3. So this becomes mg by root 3. So this is the right answer. For the determination of focal length of a convex lens, for a determination of focal length of a convex mirror, a convex lens is used because the convex mirror produces a virtual image. So you cannot get it on the screen. So you use a convex lens. It is impossible to obtain the convex lens as image produced by a convex lens. The convex mirror always forms a real image. No, this is the right answer. The first one is the right answer. It is not possible to obtain the image produced by the convex mirror on the screen. So this is the right answer. So the next question is, so the particle moves along x-axis with the initial position x. You are given, it is a Vx graph. And they are asking you what is the acceleration graph here. So we know that acceleration is equal to, acceleration A is equal to V dV by dx. From this picture, we find that dV by dx is negative because it is slanting in this direction. So the theta is obtuse here. So tan theta is equal to negative here. So dV by dx is negative. So if the slope of that line is m, so this will give you minus Vm. So we can easily observe that here V decreases here. So when V decreases because of this minus sign, A should increase. So A initially will take a negative value here and then it is increasing here. So this should be the right answer for this one. So very, very important concept to note down. Acceleration, apart from you have acceleration is equal to dV by dt, you also have acceleration is equal to V dV by dx. Whenever a Vx graph is given, this is the way you find the acceleration. It is the product of the velocity at that point and the slope at that point. So next question is, choose the wrong statement regarding the experiment to identify a diode, an LED and a resistor. When a pointer moves in one way, when the voltage is applied and does not move when reversed. Yeah, it does not move when reversed because here it is given as an LED. So LED is also a diode. So when the voltage is reversed, it becomes reverse bias. During reverse bias, there will be no conduction, so the pointer is not moving, and the light emission is there. So it is an LED. So this is a correct statement, but they are asking you the wrong statement here. So when a pointer moves in one way, when the voltage is applied and does not move in reverse, and there is no emission of light, the item is a diode. When a pointer moves in one way, when voltage is applied and does not move in reverse, and there is a light emission, the item is LED. So sorry. It's the second point. When a pointer moves in one way, and when voltage is applied and does not move in reverse, there is no emission of light. The item is a diode. The item is a diode. Yes, this is the right answer. Because for a diode also, when reversed, it does not move and there is no emission of light also in an ordinary diode. Only in LED is a special type of diode where there will be a light emission. So the third point is when a pointer moves in one way and voltage is applied and not when reversed, it is a resistor. So this is the wrong statement because in a resistor, when the voltage is reversed also, the pointer will move. Because it doesn't bother, if the pointer moves in one direction, the pointer will move in another direction when a resistor, for a resistor. So this is the wrong statement, and for this question, this is the right answer. This is the right answer for this question. So the next one is, a light ring of mass m and radius r lies in the xy plane with its center at the origin as shown. The mass distribution of the ring is non-uniform such that at any point P on the ring, the mass per unit length is given by lambda is equal to lambda. This is a varying mass. It's a varying mass. It starts with its maximum at this point and then it decreases and becomes zero here. And then again it becomes maximum here. Because it's a cos square theta, it doesn't take a negative value. So it's a varying mass. But the thing here is, even though it is a varying mass, all the masses are located at the same distance from the center. So since this is the same, so even though the varying mass, the total mass is going to be m. So all the, even though it is a bit of masses, all the masses are at the same distance m. So the answer should be m r squared only. M r squared, because if you take this is dm means, a small part if you take and this part is some dm means, or dm1 and this is dm2 means, the moment of inertia of this part is going to be dm1 times r square and this is going to be dm2 times r square. When you add all the dm1, dm2, dm2, dm3, it will give you the entire mass. So the answer is going to be this one. This is going to be the answer. So the next question. What happens when we do not stir a mixture continuously in the experiment to determine the specific heat capacity of a given solid? When you don't stir the mixture continuously, the temperature will not be constant. So that is the reason why you stir a mixture during specific heat capacity experiments. So the temperature will not be a constant. So this will be the right answer. So this will be the right answer. Here, this will be the right answer. Next one. Next question is, an ideal monatomic gas with a pressure P and volume V and temperature T is expanded isothermally to a volume 2V. When it is expanded isothermally, so it becomes PV is a constant. The product of pressure and volume is a constant. So initially it is PV. So it will be PV is equal to, finally the volume becomes 2V. And the pressure will become, pressure they are given as PI. So Pi into 2V. So Pi is equal to, so you get Pi is equal to V and V gets cancelled. So Pi is equal to P by 2 you get. Pi is equal to P by 2. So next one, it is adiabatically. The same gas is expanded adiabatically to a volume 2V. So when you So adiabatic expression is PV power gamma is a constant. So it is P V power gamma. Gamma is 5 by 3 for a monatomic gas is equal to P into 2V power gamma. P into PA. Again, the new pressure is PA. Adiabatic process PA into 2V power gamma. V power 5 by 3. So this V power 5 by 3 and V power 5 by 3 gets cancelled. And this 2 power 5 by 3 is there. So here PA is equal to P divided by 2 power 5 by 3. So they are asking PA divided by PI. So PA divided by PI will be PA divided by PI will be 2 divided by 2 power 5 by 3. So this is power 1. 1 minus 5 by 3 is minus 2 by 3. So this is going to be 2 power minus 2 by 3. So this is going to be the right answer. This is going to be the right answer. So the next one is question number 11. In an Young's double slit experiment with a light of wavelength lambda, the fringe on the screen width is beta. When the two thin transparent glass plates of thickness T1 and T2 are placed in path of two beams, respectively, the fringe pattern will shift by a distance. So when you are going to place in a Young's double slit experiment, say this is the Young's double slit experiment. When you are going to place a transparent medium of thickness T and one of the light path and a refractive index mu, then shift will be, if this is the screen, if this is the center, all the fringes will get shifted by distance. Actually, d by d by d times mu minus 1 into t. Mu minus 1 into t. We also know that beta is equal to lambda d by d. So this d by d is going to be beta by lambda. This d by d is going to be beta by lambda. So this is going to be beta by lambda times mu minus 1 into t. Mu minus 1 into t. So this is the shift formula in terms of beta. This is the shift formula in terms of capital D and small d. Capital D is the distance between the double slit plane and the screen, and small d is the distance between the double slits. So this is a relation. So the thing is that when you put the transparent plate on the upper plate, the shift will be upward. When you put it on the downward plate, bottom slit, then the shift will be downward. So here they are keeping the transparent sheets in both the ways. So it should be subtraction of this one. So beta for upper plate it should be T1 beta by lambda times mu minus 1 T1 minus beta by lambda, because T1 is given greater than T2. So that is why I am subtracting T1 by T from T2. T1 minus T2 I am doing. Beta by lambda times mu minus 1 into T2. So this is the final answer. So that means beta by lambda into mu minus 1, you can take it common outside. So it should be T1 minus T2. So this should be the right answer. So the next question. Consider a Gauss law for this one. Which of the following statement is true? Here. E must be, this is the correct answer. If the only charge inside the Gaussian surface is an electric dipole, then the integral is 0. If this is an electric dipole, then the total charge enclosed is 0. So the integral is 0. The integral of this term is equal to 0. So this is the right answer. So this one is the right answer. So the next question is, a dipole consists of two charges plus q and minus q joined by a massless rod of length L. Is seen oscillating with a small amplitude of a uniform electric field of magnitude E and period of oscillation. The period of oscillation they are asking you. The period of oscillation generally, it is given the rod is massless. And in the formula, they are giving the period of oscillation. Usually the dipole torque is equal to what is the torque usually you get? The torque is going to be the restoring torque. So tau is equal to P sin theta. P is equal to Q into L into E sin theta. For small angles, you can write sin theta is equal to theta. So since this is a restoring torque, I put a negative sign here. So alpha will be equal to tau by I, tau divided by I. So this is going to be minus QLE by I times theta. So this term is going to be when you compare it with the simple harmonic accelerations, alpha is equal to minus omega square theta. So this term should be omega squared. So omega should be equal to square root of QLE by I. So time period should be equal to 2 pi by omega. So that should be equal to 2 pi times square root of 2 pi by omega. So that's omega is you have found omega. So that should be I divided by QLE. Here I is the rod is given to be massless rod, so that will not have moment of inertia. And this is not the answer. A is not the answer because it is given proportional to E, but it is inversely proportional to root E. So this is also not the answer. So here in this two, it's proportional to 1 by root E is a right answer. It's proportional to 1 by root E, but not equal to pi times ml by Q3QE. I should be equal to, in case of a rod, if this one is M and this is M, and about this point, this is the moment of inertia of this one is, I should be, for this one, if this is M and this is M, it is ml squared by 2 plus ml squared by 2. ml by 2 the whole square plus ml by 2 the whole square by 4. ml square, L by 2 the whole square this is. So this is also ml squared by 4. That will give you ml squared by 2. So when you substitute I is equal to ml squared by 2, you get 2 pi times square root of ml squared by 2 QLE. You can cancel one L and one L here, and you will get, when I take this 2 inside, it will become 4. So 4 gets cancelled. So it should be pi times square root of 2 ml by QE. That should be the right answer. So it is not equal to this one. So this should be the right answer. The next question.